The wet corrosion. Today's topic, which I would like to discuss is about the wet corrosion, which is also called as an electrochemical corrosion. This type of corrosion usually takes place in the presence of moisture. The reasons why we call the wet corrosion as an electrochemical corrosion is just because of two reasons. One thing is when the conducting medium is in contact with a metal, and the other is when two dissimilar metals are connected together and are exposed to the when the two dissimilar metals are connected together and exposed to the conducting medium. So these are the two reasons for why we call the wet corrosion as an electrochemical corrosion. And here, as I said you, the wet corrosion is also called as an electrochemical corrosion. So when an electrochemical cell is being formed, the cell contains two regions. One is an anodic region and the other comes the cathodic region. So in case of anodic region, the oxidation takes place with the liberation of free electrons, whereas in the cathodic area, reduction takes place. So the reduction is taking place by consuming the electrons. So here, the cathodic reactions, they consume the electrons either by the liberation of hydrogen gas or else by absorption of oxygen. So cathodic reactions consume electrons with liberation of hydrogen gas and absorption of oxygen. So here, coming to the evolution of hydrogen gas, for that case, we take a particular metal, let us take an iron metal. That iron metal is in contact with an acidic medium. So the acidic solution which I have taken is HCl. So the iron metal, when it is in contact with the HCl solution, the rate of faster would be faster. The rate of corrosion would be faster in case of acidic medium rather than that of the basic and neutral medium. So here, as I'm exposing the iron metal to the acidic medium, that is HCl solution, so immediately the iron metal undergoes corrosion. It means the iron metal undergoes oxidation. So Fe plus 2 gives rise to Fe plus 2 electrons. It means the iron metal is undergoing oxidation when it is in contact with the acidic solution, that is HCl. So when iron metal is undergoing oxidation, it liberates Fe plus 2 ions. Along with it, electrons being liberated. So these liberated electrons tends to react with the H plus ions of acid, thereby produces H2 gas. So in this way, the hydrogen gas is liberated when an iron metal is in contact with the acidic solution. One thing which we need to remember in this case is the rate of corrosion would be faster in acidic medium rather than that of the basic medium. So here, in case of liberation of hydrogen gas, we find a large anodic area and a small cathodic area. The large anodic area is, as I said you, the rate of corrosion would be faster in acidic medium. So as soon as a metal being exposed to the acidic medium, faster will be the metal to undergo corrosion. The areas which remains unaffected, those areas tends to act as a cathode. So in this case, in case of liberation of hydrogen gas, we find a large anodic area as well as small cathodic area. Next, coming to the next type, that is absorption of oxygen. So in case of absorption of oxygen, we just take an iron metal. That iron metal is being exposed to the atmospheric O2. Like for example, here in this diagram, I have taken an iron metal, and that iron metal